In this video we have a ThinkPad W700 on the left and a ThinkPad W520 on the right. And this is really a comparative overview of performance. What we really want to see is the speed of typical tasks that I do with these laptops. One on the left's about 3 years old, one on the right's a brand new Core i7. So slightly different video resolutions, both are 1920, but one's 1200, the other is 1080. I'm going to hit enter at the same time and start the stopwatch. We'll look at how long Camtasia takes to start. So I'm pointing to a half, let's see, they're both in rename mode, there we go. I'm pointing to a 542K file, so about a half a gig file, and let's see how long it takes to launch. 3, 2, 1, oops. Oh, I missed the stopwatch there. So this is off a solid state drive on both of them, an identical Kingston SSD now 96 gig drive. Alright, let's repeat that. Because there shouldn't really be any kind of like hybrid-like learning function, just running it twice, there might be some Windows caching going on. I just want to see what happens the second time. Let's see if I can get my thumb right on getting the stopwatch in the right. Properly done here. I'm going to click with my thumb first and then my four fingers here. 3, 2, 1, start, enter. That looks good. About 7 seconds on the right, about 13 seconds on the left. That's quite a difference already. So now I'm going to set up a rather typical producing job. It's warning me I got to drag it to the timeline. So I drag it to the timeline. Recorded dimensions. Click OK. Produce and share. Let's produce it at 1280, 720. And do the same over here. Drag it to the timeline, choose recording dimensions, click produce and share, choose YouTube style 720, leave it untitled, and I'm ready to hit enter on both keyboards, which will finish and start the rendering job. So here we go. In 3, 2, 1, start, enter. Could not find first frame. Do I want to continue? Yes. 3, 2, let's reset. 3, 2, 1. Okay, so now we have a progress bar. Not sure that's visible on the video. But what's happening here is, on the left, yeah, we're getting quite a speed boost, 30–40%. I wish I could make this progress bar a little bigger. I'll go ahead and zoom in on the camera, make it more obvious what's going on. And let's get the stopwatch in there as well. Let's think about how to do this. That should work. Yep, this will work. Okay, so I'm going to drag this nice and tight, and I'm just going to try to show the difference in speed for a Camtasia job. Something I do fairly often, so for me this is meaningful at the Core i7. Makes a significant difference for me doing such a task. I'll know soon. Already looks like we've got one quite a bit ahead of the other. Try that again. Okay, so yes, we can see the rendering is going quite a bit faster. This one's 11, this one's 7.6. Okay, so I guess the best thing to do now would be to go ahead and pause the video, and we'll see when it finishes, how far apart the two are. Alright, so the video is 2 minutes in. Go ahead and pause it and resume when done. Okay, I unpaused the video because I was thinking about looking at watts here. So I'm going to bring up the power meter and slide that into view. So you'll notice that I'm not actually cranked all the way to high performance. I thought I had done that before filming. I obviously have not. I do find it interesting that I'm burning only 38 watts of power. Right here on the mouse, 35 watts of power. That's impressive. Screen on full brightness. Now let's look in the W700. Slide that over, and you'll see the watts do not show, but you will notice it is on high performance mode. Okay, so we're kind of go back to that. Go back to this machine. I also notice Turbo Boost is disabled. Right here, this button says disabled. So I'm not quite at high performance. Don't have Turbo Boost disabled. So what this means is I should run the whole test again, using a different file to avoid possible caching issues. I'm thinking here, this could be interesting. I want to see if Turbo Boost uses more power, and does it do anything for my rendering time. So actually I'm going to let it go. This is still a good test. Let's show the CPU here. This is interesting. So you got this multi-core stuff going on. You got hyper-threading on the right. That's apparently not really doing much with half the cores. So you can see 4 cores busy. And on the left, all 4 cores busy. On the right, of 8 cores that show 4 physical, 4 just hyper-threaded. Camtasia, apparently, its MPEG-4 rendering that it's doing does not take advantage of hyper-threading, apparently. Okay. I'm going to cut this test off at 50% done rendering. That'll help limit this length of this whole video here. So this is at 46%. When we get to 50, I'm going to kill the rendering. And I'm not going to worry too much about caching because all I'm going to do is restart the same job. I'm going to kill both jobs at 50 and then restart the whole thing after sliding this performance tab all the way to the left. Okay, so 49%. And 50% at 7.5 minutes. So I'm going to cancel that job. That one's ready. Now the one on the left, I also want to let it finish or get up to 50%. As I hit the stopwatch, it was at about 35, now it's at 37. So just making some notes. Alright, so let me bring up that power wizard again. And let's just see here what happens when I turn on Turbo Boost. So Lenovo Turbo Boost technology. Let's get a description of that. Optimizes fan speed for best processor performance. So that's unlikely to do anything other than crank up my fan. But let's give it a try. Oops. I hit something I did not mean to. There we go. So turn on Turbo Boost. Fine. And the energy watts had gone down to 16 or 19. I hear my fan up because it's not doing Camtasia. Fan ramped up, goes back to 29. Okay. Excuse me, 19, 17, 24, 18. Alright, so it's bouncing around. Let's zoom in a little more here. So watch these meters on the right. And again, I'm trying to show what does Turbo Boost do. We seem to be between 17 and 23 watts between Camtasia rendering jobs. Turn off Turbo Boost. 22 watts, 15 watts, 16. I don't know if the microphone's picking this up, but yeah, we've reduced the watt burn slightly, and the fan is a whole lot quieter. Alright, so for the second run, let's go to high performance. Let's turn on Turbo Boost. Make sure the screen is fully brightened. On the left, looks like it was just slightly under bright, full bright. So now we're ready for a second run. And the machine on the left is also done. So I'm going to close the power meter. Let's zoom this back out so you can see what's going on. This power meter was already cranked to high. And Camtasia, we're going to cancel now that it's at 50%. That took 10 minutes and 20 to get to where the other one was. So looking like a 20 to 30% boost somewhere in there. So the wizard's asking me what I want to do with the production. I'm just going to hit back arrow to get back one step in the wizard. Okay, looks like we're good. Next, next. So I'm going to want to hit enter at the same time again. So here we are on round 2 of rendering. Why one shows a preview and this one doesn't? Or the Windows 8 video I recorded, I don't know. Okay. 3, 2, 1. Same question. Do I want to continue without a thumbnail? I'm going to say yes. Okay, there they go. Let's get rid of distracting stuff. Let's put the CPU core meter here. Let's put the progress bar here. Same over here. A second, let me line it up like that. I got a docking thing turned on, so it's messing with the position, but that's alright. Okay, and then let me zoom in a little. Okay, so now we're seeing something interesting. On the right, for a little bit it looked like all the cores are being used. That didn't happen on the last run. Not sure what to make of that. And it's happening again, where 6 of the 8 cores are busy. Okay, now it's settling into a pattern where some of the time only 4 of the cores show again. It's all a little odd, but anyhow. On the right, 8%, left, 5%. Okay, it's quite a bit ahead. Okay, W520 on the right, 10%. On the left, 6.6%. That's 1/3 difference. Wow. Okay, I'm going to pause the video until I get to the end, or near the end, on the 520 on the right. So we can see how much time has elapsed on the stopwatch. actually to do a comparison with the first test, let me take that back. When the machine on the right gets to 50%, that's when I'm going to resume the video to show at what point that happens. Alright, on the right we're at 48.7%. We're almost there. So the first time it took 7.5 minutes to get to 50%. This second run, it's taken about the same at 49.50. Okay, 7 minutes 15 seconds, second run. And on the left we're at 33.6% again. So we're seeing that same ratio, meaning it'll be 66% on the left when the one on the right is at 100%. So no great shocker there. We're also seeing a continuing pattern of more than just 4 bars showing there. It seems to be spreading the load a bit better. So next thing I think I want to do is compare the watt burn of these two using an actual watt meter. So I'll do that in a second video here, but I'm going to go ahead and use one of these and we'll see the actual watt burn. I'll have to pull out the batteries and plug in the laptops. Thank you for watching. Alright, this video is intended to show the power consumption of 2 laptops. 2008's W700 model and 2011 Core i7 W520 model. Let's start with first turning on the power strip. Alright, push down. Okay, so we are at 27, okay, 2 watts and 0 watts. I see a moon icon on both, and anyhow there's a difference right there, and this one's spiking up to 21 as it's looking to charge, I guess. You'll see the giant power brick is similar in both. They're both actually 170 watts. You can see right there, particularly if you're watching this in high def. And let's try unplugging this. Obviously that number should drop to 0. Well, not quite to 0, to 1, so a little bit of phantom power. Let's try this one. 0. So already seeing a bit of difference here. This one's truly asleep, and I guess the battery's charging, so that's the difference. The battery's actually kind of old on the left. Next thing is to remove the battery, speaking of batteries. So yeah, it's on sleep mode. And so we can get the operating system back, but we can rule out any kind of battery charging. And now you see it drop down to 2 watts. Alright, so we're at 2 plus 2, 2 and 2. Now it's time to fire these up. Alright, so what are we seeing for watt burn? Well, we're actually seeing a considerable difference already. So you'll notice 30 and 69, 57. Okay, it's bouncing around a little, but you can see there's obviously a difference, left versus right here. So let's show the power profile here quickly. So Camtasia is set to solid state drive, Kingston SSD on both machines. And so identical hard drive. Alright. These machines were cloned from one another, so it's the same hard drive. And let's crank this to high performance, click apply, turbo boost enabled. And it says 22 watts on the screen. You can see that. Let's see how accurate the watt meter is. So it's saying 22 watts. This is saying 34. So that is not matching. Just to show there's no trickery going on here again. You can see that that's it. It's plugged in directly to this laptop. And I've pulled out the battery. So I find that interesting already. So there's a bit of a discrepancy in accuracy in the readout. Fine. This one, the power meter doesn't tell you number of watts. So I guess on a W700 it never claimed to have a live look at the watt burn data. Alright, so let's move on and let's see how we do under load. So at this point I'm going to pause the video and get set up here with Camtasia. Actually I don't need to pause it, never mind. So both machines have Camtasia running with the same job from a previous video I recorded tonight, showing the difference in time and rendering. Now we just want to see watt burn while Camtasia is running. So while they're doing the same MPEG-4 encoding task, 720p, untitled, next. Produce and share, 720p, untitled, finish. Okay. So let's now see what happens to the watt consumption on the quad core versus the Core i7. I would like to see CPU as well. Yeah, let's get started. Okay, they're both asking to overwrite a file. So 3353 goes to it's kind of interesting. So they're pretty much neck and neck for power consumption. You'll notice the CPU meter here is showing all the cores busy. So let's zoom in a little bit. We've got the progress bar, we've got CPUs, we've got both of them cranked to max high performance, and now we are definitely seeing a difference here that's considerable. Now the machine on the right is obviously winning. It's at 9%, this one's 4.5. So we're doing a whole lot better for speed on the right. The one on the right is saying 658, which does not match this number, so 6751, 6754, 7052. It's definitely reading low there. Alright. Let's focus just on the watt burn then. So now we're getting more work done for what looks like about 11 watts, 12 watts less using the Core i7 on the right. So it's doing a better job at doing this video conversion. Plus it's getting the work done faster. So it's burning less watts and it's going to spend less time working so hard. 17%, 9%. So we're getting almost double the speed here, which is interesting. Let's see what happens to watt burn when I turn off this turbo boost feature. So we seem to be around 68 to 71 with it on. Let me turn off the Lenovo Turbo Boost, which just cranks up the fans. I don't know, we say maybe 5 watts. No, not even. I don't know if it's picking up the sound on the camera here, but it's quieter. Alright, 25%, 13%. So if we come up to a third of 100% here, it'd be easy to figure out what percentage that one's done in comparison. So I'm going to get to 33 on this, and we'll compare that to the number over here. So W520 on the right is now at 33.3, 18 over here. Alright, so that's really what I wanted to show off for this video, was to compare under workload, the, well, kind of completion times. That's one thing we've noticed, that obviously the one on the right is going quite a bit quicker, but also watt burn, how efficient each system is at handling this workload. So we've got 18 times 3 is 54, and 33.3 times 3 is 100%. So when this one gets to 100%, if we extrapolate out, this one's going to be at only 54%. So we are almost double the speed with the Core i7 on the right, and we are between 10 and 15% less watt burn. Make sure both screens are in full brightness. They are. So that really ends this test. Hopefully you found this interesting or helpful. Okay, we're nearing the end here. I want to point out a couple things. I brought up the graph showing about 11 gig left, 10.7 about 11 gig left. So they have not only the same Kingston SSD drive in there, but the same amount of storage left. Very close anyway. And the other thing I want to mention is, let me show you Device Manager, disk drive, Kingston, there it is. The C drive is the only relevant drive. That's the one where the temp file is set to in Camtasia. And that's where the file is that it's rendering. So again, let me just show a quick look. Kingston, SPP 100. Same drive. Okay. More important is, okay, we're at 97% now. So let's check that out. So here we are, 97% done. And let me get this video window ready on the other machine. So it finished. Now let's look over here, and that's only 54%. So that's as expected. Notice the CPU use dropped dramatically on the right. So we're burning a lot less now that the Camtasia rendering is done. And that's about it. I did notice the 8 cores were busy, so it seems to be multi-threaded, and they weren't all at 100%. So as I brought up this little pie graph, it was very responsive to the GUI even while Camtasia was running. Didn't really have any problems with it acting sluggish at all. So that's the end of showing MPEG 4. Sorry for the video cut there. I just wanted to add this little additional video just explaining that the hard drive space left on these solid-state drives that were cloned from one another about a week ago is very similar, because that could definitely affect results if you run low in space with solid-state drives. And also point out and show that it's actually the same exact model of Kingston running. There's the last piece I just thought of, and that is the firmware on the Kingston. So if we go to Device Manager again, device manager and we look at the actual drives, let's do it over here. Okay, and then we right click, properties, get this video going right here. Okay, oops, sorry, details, change that to hardware ID, and now you can see all the relevant details. So there's your firmware version, 10202. Let's do the same on the right. (10202). Same firmware running on both. Okay. So again, hopefully you found this informative. We got to look at watt burn. We got to look at how much quicker one machine's running than the other. And here we are several minutes later, and this one still has a long way to go to finish the video rendering. Thank you for watching. By the way, the video was set to NVIDIA Optimus. And the machine on the right is still cranking along. The machine on the left, excuse me. So Camtasia was defaulting to any kind of GPU intensive app runs under the GPU accelerated mode, is my thinking. I haven't actually thought too much about how one makes sure you know which is processing a particular app, the GPU or CPU. Not really sure. We can look at the properties of Camtasia Studio, and we can particularly we can force it to run with a particular processor. Let's look at the default. Can we tell what the default is? Not really, because Camtasia is not listed here. So Google Earth is the one app I played with. It can be pre-configured with a few others, it looks like. But again, I don't quite know how to look up which it was running with, but whatever it was doing, it was efficient and fast. And in the video, I should be able to see the time on playback. So now it's 10:05 p.m. and this machine is almost finally done. You'll see the large difference in screen size, obviously. 17, 15.6, 1920 by 1200, 1920 by 1080. The hinges, the machines are lined up nicely here, and now you can really do the apples to apples comparison of screen size. Quite a difference. Alright, 100%. This thing just finished. So there you go. It's 10:06 p.m. Finally, that's a wrap.